Okay. So smile, because you're all about to be on Instagram. Okay. That's a Voronoi diagram, for those of you interested. So I'm going to begin. It's a good time to begin, yeah? Everyone is ready? Great. Okay. So let me open up. Okay. Okay, so my name is Kogan, and I'm an artist and I'm a programmer. And like all of you, I'm an advocate for open source software, a proponent and a contributor. I don't think here this is not the place to evangelize open source. I think we're all sort of on the same page with it. But in case you're interested in some of my work, you can check out my website at genekogan.com. I'm also on Twitter under the same handle. And for those of you, I'm sure all of you are going to be interested in my GitHub, which I also have an account. Let me tell you a bit about myself. So I'm from New York. I've been living in New York for the last 8 years. I went to college there and I studied applied math and machine learning while I was there. And I didn't really, besides for some of the programming assignments in machine learning classes, I wasn't really formally trained as a software developer or an engineer. So I don't really have formal training, and I don't really consider myself a software engineer. I struggle with pointers and templates and all those sorts of features. But I do code all the time. I code a lot of things. This is all coded using processing, which we're going to get into. And just to maybe set a bit of a context for what I'll be talking about, I'd like to show just a few of my works, what I've done, and you'll kind of get a sense for what you're able to accomplish using the software stacks that I do use. As an artist, I'm really interested in a field of art called generative art, which is the idea of creating artistic forms using code, using algorithms. And for example, let's see if I can find these guys. So one example, there's a recent project of mine in which an artist named Philip Stearns and I collaborated on a project to fabricate seashells. Essentially, what are seashells? I'm going to open up this program. And I wrote this software to basically model algorithmically meshes that look like seashells. And you can find all of this online. Right? So I'm not going to belabor this too long, but there's all sorts of presets. You can see there's a control interface here that lets you generate different kinds. Right? So if I change some of these and then regenerate, you will get an all-new sort of looking thing when it works. It's got a bunch of presets, so I can open up one of these presets and get a totally different form. So we made a whole bunch of these, and we actually fabricated them using 3D printers. And we had them on display at a festival called Soundwalk in Los Angeles. And the whole idea was to get people to interact with these fabricated seashells, because a lot of them were inspired from nature, but a lot of them are actually totally, totally imaginary, just parametric. And we had them on display. You can see this right here. It's called Listening to the Ocean. And we actually fabricated them using a gypsum printer, 3D printer, which was done by a third collaborator of ours. And they come out looking kind of like this. These are some of the examples. Let me find one of the more complicated ones. So you can see that the printing can be quite intricate when you're using some of these sort of more industrial-sized printers. The image overloads. There it is. I do a lot of this sort of very simple generative artworks that I also like to put online on the website called Open Processing, which is a website that allows you to share code with people, share source, and share generative processing ideas. So I'll just pick one which I wrote, which is basically just it generates stars, generic stars, essentially, because we think of stars as being your typical 5-point star, but a star can have many points. A star can have many strategies for connecting those points. Uh-oh, that's not good. Like, that's okay. I have it here also. So let's open that locally. And this one works. Great. So when you click on these, you'll get all, just sort of an infinite variety of different looking stars. And they follow a simple algorithmic procedure. Pick a random number of points and skip a random number of points and basically just go around until you finish some random shading strategies, and you get lots and lots of variety. And then just another one is called vertex rivers, which is, let's change this. So I'm using 2 versions of processing, so I have to occasionally code on the fly. It's okay. It'll be fine. Great. So this is something that I've had. Again, this is modeled from physics, and it's very sort of a very typical generative work. You'll see lots and lots of these kinds of things online. I'm also really interested in performance-based generative artworks. So things that I can actually control on the fly, building instruments and so on. So a good example of that is something I've been recently working on that I intend to use in performing live music or working with musicians is something that looks like this, which I'm going to have to open it in the older version of processing, otherwise it won't work. So I'll open this. Right, so you get this sort of, actually let's make it the whole size. Okay. So you get these sorts of, I'm using a typical recursion algorithm, which splits. It'll be better to look at this actually in this view, this rectangular view. So every time I generate one of these, it basically just uses recursion to create these sort of semi-autonomous rectangular boxes with different colors. And every time I click the space bar, I'm getting a completely different one. And I can have these sort of rectangular, or I can wrap them around the center and have them radial. So these are the same, except that I'm using a shader basically to just put it around the center point. Okay, and these also move. Right? So if I can kind of control these, I'm just hitting the keyboard kind of randomly. And I just like to build these sorts of visual instruments that I can use in sort of performative context. So it's not just for music. I've done things in dance and in theater as well. I participated in something called Tip of the Tongue, which was a dance show in which I created these graphics that were corresponding to the dancers in real time. So I have some images from that show that was in Brooklyn earlier this past spring, where we were basically, there's a wall projection that is generating, again, in real time. We had aerialists, we had dancers, we had people on these huge spinning cylinders. It was actually quite extravagant. So my part was just sort of making it, well, putting in some graphics and letting them make me look good for the most part. We did some stuff projection onto people's bodies. These are both examples of that, where the projection was using computer vision to find where the person was and then just project only onto there. So these are some examples of that. And all of these have to be sort of instruments that I have to build that work in real time, because the performance won't always go the same way. So that should give you a good sense of what I do. I really, well, unfortunately this isn't working, but I really enjoy, this is all the code that you just saw. It's all online. There's a website called Open Processing, which lets you share code among other processing programmers who are interested in learning how to use processing or interested in learning about different algorithms. And I have a bunch of programs up here. You can see the C-shell generators here, subdivision, some of the ones that I showed you. And at the same time, I also have a bunch of stuff up in GitHub, which I'm also a big proponent of, mostly because it really allows me to learn from other people's code, and often some of the projects that I'm most interested in are hosted on GitHub. So The subject of the talk is basically about open source art technology, and specifically how the open source movement has really sort of how it's impacted certain strains of art online in the form of these open source tools, which have really greatly lowered the barrier of entry to creating, to using code in a creative way. So I'm not an art critic or a historian or anything of the sort. But I do want to kind of set the stage a little bit and tell you a little bit about a little bit of the history and sort of talk about some of the issues that have come up regarding the application of open source to art. And a lot of them are going to sound very familiar to you because there are a lot of the same kinds of issues that come up in open source software of any kind. But there are a few key differences that have that are unique, and it'll be interesting to dwell on a little bit. I'm going to focus on two software packages in particular, which are called processing and open frameworks. And I'm guessing lots of you have heard of them. So can you raise your hand if you've heard of processing or if you've used it? Okay, a good number of you. Looks like maybe a quarter or something. Anybody here familiar with open frameworks? Anybody? All right, at least one? Okay, a few people. All right. So open frameworks is, as you might expect, much less well known. I want to talk about those particular ones because they'll illustrate some of the major topics that are going to be interesting to you guys. So let me talk about processing first. So for those of you who don't know about processing, processing is a programming language. And I say programming language in quotations because it's not really a programming language, it's just Java. But it's a little bit more than just Java in the sense that it was designed for people who have no prior coding experience to get started very quickly. So if you open up the processing application, you download the processing application, and it looks like this. Sorry, let's open the blank sketch. You just get this small, very self-sufficient integrated development environment, and you write your code in here. And you're writing Java, but processing understands things like this. Ellipse. Okay, that's probably hard for you guys to see, so let's just make that a little bigger. You're writing things like this. Ellipse, 50, 50, 100, 100. And this will compile by itself, and you get something like that. So there's so much hidden beneath the surface of this program that I think this crowd should be all too familiar with, right? So setting up a window and the fact that a computer doesn't naturally know what ellipse means. And there's all this huge software stack that's implemented beneath the surface. And when this program gets compiled, all of that stuff which has been done for you is compiled with it. And the idea is really that, again, so much of the grunt work has been taken care of. And every artist who wants to make digital windows on their computer has to deal with the same problems constantly. So this was kind of trying to address that. And it came out of the MIT Media Lab. Two students named Ben Fry and Casey Reese, who were in a group called the Aesthetics and Computation Group at MIT under a professor named John Maeda. And they were using something called ACU, which was their sort of MIT's proprietary soft coding environment, which did more or less the same thing. But they were really interested in making it available to a larger audience, and so they decided to make their own version of it, which would be completely open source and available and hosted online and have a number of contributors. And the initial purpose was really because at the time, this is the early 2000s, like 2000, late 90s, early 2000s. And at the time, there was already a very well-established digital art scene. There was lots of people making art. But they were using programs like Photoshop or Flash and things that were Flash. You could code a little bit, but it was also third-party applications made it much easier to use. And the reason was that no one really expected for artists to be very good at coding. There was much more of a division of labor at that time. But these guys wanted to get some of their students to start thinking in terms of code. And they wanted to make it a little bit easier for them to approach the subject and get into it. And even though this is really meant to be easy, it actually has turned out to be quite powerful in its own right. And you can push it quite far. So what does the processing environment take care of for you? What's underneath it? Well, the process of creating a window is taken care of. Integration with your graphics card, OpenGL, is taken care of. Primitive graphics like circles, rectangles, lines, Bezier curves, filters and blurs, and lots of different things that you would find really in Photoshop are taken care of for you. They're implemented, and you can call them with a simple command. And besides for that, there's libraries that integrate sound and webcam input and interactivity with the mouse and the keyboard and interactivity with peripherals and so on. And it really, really makes it quite easy. So, and I'm going to show you a few example programs that will demonstrate just how easy some of these things are and how it really facilitates the process for someone who may not know how to code their own drivers or may not know how to look at really esoteric Java libraries and integrate them. Or for someone who just doesn't have the time to do that, it's really made it much simpler to get started. And now you have really kind of a legion of people, a lot of people using processing for this kind of work. And so I want to give you a little, just a demo of what it can do. So this is just a basic programming patch, right? But you can, let's say you want to make the size of it a little bigger, right? Simple command called size, right? And you just will put it here. I can easily put the mouse, can control this with the mouse simply by replacing 50-50 with mouse X, mouse Y. Right, so, oh, of course, I can't do it yet because it's not in the draw loop. So let me, before I do that, let's just put this into the middle of the screen. And let's make like a rectangle, also just in some random location that's this big. Right, and let's make the ellipse red. And let's make the rectangle green. And you can see the simplicity of these commands, right? So the fill color is what makes these shapes go. Every processing patch, almost everyone, will usually have at least two methods called setup, which is just short for call the one function that happens exactly once at the beginning of the program, and then call the draw loop, which gets repeated, which gets continuously run 60 times per second. Or if you set a frame rate differently, then it gets run differently. So let's say, for example, I replaced mouse X and mouse Y, and on every draw loop, I cleared the screen with a background command. And now I have something that looks like this. So obviously, this is super dinky, but what I'm really trying to show you is that how easy it is to make moving graphics without really a whole lot of importing weird libraries and things of that nature. There are all sorts of ways that you can take this, and there's other commands. But what it really does, it has all the features of Java available to you. So you can create loops and create iteration, and you can, for example, do something like this. So let's clear the screen. Let's make a white background, and let's just draw an ellipse in every frame. That's going to give us a random location and a random size up to, let's say, 100, between 50 and 100. Okay, and it's just going to draw these white dots, right? But maybe we want them to be a different color or something. Exactly. And maybe we want to turn off that really ugly border color. Right? And we want it to be a little smoother. So if you run the smooth command, you'll turn on the anti-aliasing filter, which again is another feature that's built into the language for you. And so on. And maybe we want to give them a little bit of transparency. That's just another alpha value. All right, and we get some more interesting effects. So I teach a lot of this. I teach this class very often to people who want to learn how to use processing. And one of the challenges is always how do you get people interested really, really quickly. And the best way to do that is by trying to show them the simplest program that might make them actually find it interesting. So one of the best ones to start out with is iterating through what's called a Bezier curve. So if anyone's used Photoshop, they'll know what a Bezier curve is. It's just a way of parametrically specifying a curve on a canvas, right? And it takes 4 inputs, or 4 points. So really it takes 8 arguments, an x, y value for 4 points. 2 of the points are endpoints, and 2 of the points are these control points. Right, so if I open up Bezier curve, you can see that it's this parametric curve, and it looks something like this. You can get it to load. There it is. Right, 2 endpoints and 2 points. So what if we had those points? What if we specified them inside of a loop and had them kind of moving around and drawing the Bezier curve continuously? So that's exactly what we're going to do. And this is one of the first programs that I really show. So again, if we draw this, let's just turn off the looping. You can quickly turn off loop using no loop command. So let's just say x1, y1. We're gonna make these all up. x2, y2, x3, y3, x4, y4. And these are all going to be random. Let's just make them all random, just for the time being. These are all the 2s. And let's make all the y values. And you could probably already tell, but height and width are just variables that stand for the height and width in pixels of your screen. So let's see. So you get something that looks like this, and it fills it in by default because if you don't want it to be filled in, if you want it to be like, sorry. Oh. Oh, cool. Good? Hello? Hello? Probably turn the speakers down a bit, or turn the sensitivity down. I'll put it nearer to my mouth. It's just picking. It's really sensitive, I guess. Okay. Can you hear me? Okay, great. All right, so let's use a stroke, and we'll turn off the filling, and we'll make the background white. So this is the same. I've just picked a random Bezier curve, right? And every time we run this, you'll get a different one. It's just picking a random one. And if we turn off the non-looping, if we have it loop continuously, it's just going to, kind of put a bunch of these on the screen, which isn't all that interesting. But if we make some sort of method to our madness here, we can accomplish a little more. So, for example, there is another built-in, a really, really useful function built-in that gets overused to the max in processing, and it's called the noise function, and it simulates something called Perlin noise. Perlin noise is a procedure that is used in almost every movie with CGI graphics you've ever seen. And it kind of creates textures and surfaces that look kind of random, but are sort of organic looking and not totally random. So it's sort of like making something random, but a little bit more, give it a little bit more of an organic contour instead of just completely being random. So if you use the noise function, the way it works, and just to keep things on target, I'm not going to turn this into a class, so I'm not really going to explain it too much, but noise takes an argument, and if you keep the arguments of different noise functions close to each other, they'll give you values that are close to each other. So if this doesn't make sense why I'm doing this, let's just say I'm going to have a time variable. Right? If this doesn't make any sense, don't worry about it. It's not really the point of the talk. I'm just trying to kind of get through it relatively quickly. So if you have something like this, you're going to get a whole bunch of values that are relatively close. But we don't want them to be exactly the same, so we can kind of vary them up a little bit. 09. Just sort of, yeah, this is totally random. Believe me, it's totally random. And this may also not make sense, but don't worry about it. The reason is because noise of these will all evaluate to the same thing unless I kind of keep them separated by a healthy distance. So it's not really important why I'm doing this. The point is I'm getting noisy values. But these will always oscillate between 0 and 1. So there's a handy command in processing called map, which will take it from 0 to 1 and stretch it to be from 0 to width. And actually, an even better way of doing this is to just multiply it. So we don't have to bring that out. So all the x's get multiplied by width. So now they're going to be between 0 and width. And all the y's get multiplied by height. And hopefully this looks interesting. Okay, so you get this kind of thing that starts to move around. Well, let's make it let's give it a little bit of transparency. Absolutely. Pink would, well, okay, so this is a great opportunity to show you the color selector in processing. I'm not here to evangelize processing too much, but it is pretty awesome. So we'll take 113, 14, 112. 113, 14, 112, is that right? It'll be, yeah, let's do it. Now we'll make it pink. Hey there. And if we want to maybe like slow it down a little bit, you know, maybe we can do we'll kind of halve it. This will slow it down, and we'll get maybe some more interesting behaviors. This is the kind of thing that in one of my classes I would dwell on for a while, and we'd kind of mess with it. But here we want to maybe get to one of them is going a little too fast, so let's try to do it like this. So this will evolve a little more slowly. And instead of using noise, we can use a sine function, just easily, just like this. Now instead of, we'll have cosines and sines, so we'll get some oscillating behavior. Maybe we should make them all sines and cosines. Let's see how that looks. I'm just riffing at this point. But sine and cosine is between -1 and so maybe what I should do is put it in here, just so it stays on the screen. See what that looks like. Oh, it looks like nothing. Okay, there we go. Maybe not much improvement. Anyway, the point is you can do a lot very quickly, right? So these are some of the primitive commands, and all that's really standing before you is sort of your imagination, and all the features of Java are available to you. So if you go to the processing website, you'll see that there's a lot of things designed for beginners. There's language features and tutorials. There's a whole API available for you to read. And the most important part is the libraries. So processing isn't just a simple teaching tool, and it isn't just simple little generative sketches. You can really, really extend the functionality of processing with libraries. And over time, because processing is open source and encourages people to contribute to it, there have been something like 100 very well curated libraries on this list that you can go through. And there's all sorts of libraries. There's stuff that helps you with 3D. There's stuff that interfaces with other software packages. There's geometry tools. There are things that do simulation for you. Most notably, there's a computer vision library. So I think a lot of you might be familiar with OpenCV. It's a really well-known open source computer vision project, which has something like computer vision is obviously not a trivial matter, and so it took really a lot of contributions to create something to do any sort of good computer vision tracking of objects. And there's a port of it for processing, and you can download it and you could use it in lots of interesting ways. So for example, if you download it, processing comes with lots and lots of examples to teach you how to use it. So I'm just going to show you one of the ones that comes with the library, and it's called face tracking. Right? So let's hope this works. Okay, I'm going to open up the face tracking example. You guys can see. Hey, there I am. Hey. Actually, one of the really fun things to do is to try to trick it. I tried to do this earlier. It doesn't always work, but if you draw a face. All right, so let's, I'm getting a lot of brightness. Hey, there we go. Hey. Hey. So why would artists want to use computer vision? Well, computer vision is really useful for lots of creating interactive art. And I'm going to show you a few really nice examples of this. So the face tracker is a good, just because we were on the face tracker, one of the first ones that I want to show you is, if I can find it, where are my videos? There we go. So an artist named Kyle McDonald, basically created a program that uses face tracking to do face substitution. So so here he is. So that's him, and now every time there's going to be someone on the screen, he's going to switch faces with them essentially. Yeah, you can't see it. There we go. Now he's Marilyn Monroe. And just to bring it back to the point, I mean, what's impressive about this is that even even for hey, there's our guy. Even for software developers, computer vision is no trivial matter, let alone for artists. So the fact that it's this, not necessarily simple, but this straightforward to create an application that uses these kinds of tools shows you just how far we've come in making these tools accessible to people. And open source is obviously a huge indicator of that, or enabler of that. Sorry. Okay, that's about enough, I think. There's lots more of that. But interactivity works in a lot of ways. So another artist named Theo Watson created an installation environment for children called Funky Forest. So let's show you how this is. So basically, this senses children and it interacts with them and it creates these really cool graphics. On for a while, but you guys get the idea. So, moving back to what we have here, maybe I'll show you guys. So another really great library is called Toxic Libs, which is one of the most widely used libraries, and it's sort of an all-encompassing library that gives you, basically lets you do three-dimensional geometry and create lots of very complex graphics. And there's a really great, every year there's a show reel that comes out. This one's from 2010, of stuff that's done in processing using this library, among others. So just to show you that the graphical power of processing is actually quite impressive. That it does have, I mean, everything that, again, like everything that you can do in Java, you can do in processing. So all in processing, the same program I was just using. So lots of really nice. Let's go, move on. I'll show you one program that I made that combines a lot of libraries, which is one of the, I guess, more loaded programs that I've made. It incorporates a number of libraries. And what it is, and this has been done a million times in generative art because it's sort of it's almost cliche, but it's simulating flocking behavior. And what I mean by that is the way birds flock. You can simulate using agent-based simulation programs. And so I wrote this program using a whole number of, you can see all the code is here. It's kind of obviously very big. But let's run this, and I'll talk about it as it goes. Okay, so basically what you're seeing there in the middle, when we're going to zoom in, so I have a camera library that lets me zoom in to these birds here, if we can get closer to them. So I have like 2,000 birds that are all being simulated. And the way that they're actually, this is being generated in real time, right? So I'm moving the mouse, and I'm kind of able to zoom in on them. And the way that they know how to fly is using very simple rules developed by a computer scientist named Craig Reynolds back in, I think, the 90s, who basically said birds flock in the following way. They try not to crash into each other. They try to go towards the middle. And they try to go where everyone else is going. And through those simple rules and a little bit of algebra and some object-oriented programming, you can make this simulation. But obviously there's more to it. There's also, this is being done in 3D. And I've got these three-dimensional graphics. I have the birds flapping their wings and so on. I'm not necessarily trying to prove that well, I should mention a little bit about the software that's being used here, right? So the toxic libs library, which I just mentioned, is being used here for all the geometry. I have a camera library that I downloaded that lets me do this kind of stuff with the camera. I can do third-person camera, which will do all sorts of interesting, cool zoom-ins and so on. And I have an OpenGL integration. So what I am left to do is to specify the geometry of a single bird, implement some basic algebra, and run this. And I'm not trying to make the point that it's trivial to make this, but only to say that even 10, 15, 20 years ago, this would be a much bigger scope of a project, because a lot of these tools that I'm using didn't even exist back then. And so in some sense, my abilities as a programmer are extended by my predecessors. You know, it's not just that I don't just learn from them, but I'm actually using the tools that they wrote because they made them available and didn't copyright them or didn't closed source them or whatever. So this is what I mean by lower barrier to entry. A lot of this stuff, you know, I don't know anything about OpenGL, but I don't have to. But I do know a little bit about simulation, so that's kind of where I can use my skill set best. So let me move on to open frameworks now and talk a bit about open frameworks, which is the other. And I'll kind of do some honorary mention to a few other software stacks which are interesting. Some other. Open frameworks is very similar. It's the same, got the same sort of idea. It was developed in 2005, initiated by three people named Zach Lieberman, Theo Watson, and Arturo Castro. And basically, the idea was much the same with processing. It was to try to make this software stack that would enable you to integrate disparate libraries together to create artworks or design or whatever, any sort of creative coding. But it has a few very key differences. The most obvious difference is that it's in C++ rather than in Java. And with it, all the power of C++ comes with it, and all the headaches of C++. So, which is that, you know, C++ has such fine low-level control that you can really break your program very easily. So it's a bit less accessible than processing. It's much less accessible, actually, but still the same sort of idea. I think typically people who use it might be a little bit more hackery, a little bit more sort of a little bit better programmers. It doesn't come with like this integrated development environment. You just run it from Xcode or from if you're on a Mac, or you run it from Code Blocks or Visual Basic or whatever you want to use. And so, it kind of was trying to accommodate a growing number of people who were maybe coming from the other direction. So not necessarily artists who wanted to learn how to code, but coders who wanted to learn how to make art. And this was really for them. And to the extent that processing is open source and you know, a lot of community contributions, Open Frameworks really takes that to a whole new level. It's completely anarchical. The entire Open Frameworks core is available on GitHub, and it has lots and lots of contributors. This is the main. It's been forked, you know, countless times by many, many people. There are, I think, 2,000 forks. So So it's pretty, I mean, in the context of some of the other projects on GitHub, that may not be that many, but for this kind of thing, it's much more than any other software stack that we know of. And again, it ties together a lot of the same sort of things, taking care of creating windows, taking care of primitive graphics and OpenGL integration. And then there are lots and lots of libraries that you can access on a website I've created called OFX add-ons. So this is what I mean by anarchy. There's like 400 of these, and the way to put in an add-on, which is an extension to Open Frameworks, is to simply make a GitHub project and name it OFX something. And then they have a parser every night which picks up all the GitHub projects and puts them on this page. So anyone can contribute. There's really very little curation. There's a little bit more of that in processing. And so there's a lot of, obviously, there's going to be problems between different packages. There's lots of headaches. But it's a lot more of this very, very a big collaborative free-for-all. And a lot of people contribute to it, including myself. I have 2 add-ons that I've created here, right here, OFX Self-Organizing Map and OFX Learn, which are both machine learning add-ons that I wanted to create here. So as I said, I studied machine learning in college, and this was the way, this is very typical that someone is using Open Frameworks and might know something that's not common in the Open Frameworks community and decides they want to contribute because I'm using all these tools and I feel compelled really to contribute. And so I created an add-on for Open Frameworks that lets people create generic machine learning routines in their programs. So what's the difference between Open Frameworks? Well, besides for the ones I mentioned, obviously there's probably a little bit of a performance difference, but for the most part they're pretty cross-functional. Again, it's very anarchical. So there have been a number of really awesome projects that have been in Open Frameworks, and actually there's a show reel, but I think I'll just skip that in the interest of time. How's time? How am I? It's good? Good? Okay, great. So Open Frameworks, so there's one really great project that I'd really like to show. Is a project called, oh yeah? 5 minutes. Oh, okay. All right, in that case, I might want to skip this and talk about. I'll mention there's a great project called RGBD Toolkit, which is taking the Kinect, which a lot of you might be familiar with, and outfitting it with a camera, and like a DSLR camera, and creating these beautiful 3-dimensional visualizations. Maybe I want to actually show one of them really quick. It's this. I'm going to go very quick because I want to get to some of the good stuff.
And I'm highly addicted to programming. You can't stop me. Sometimes I forget to eat. Sometimes I forget to sleep. And I don't know, can you turn a pickle back into a cucumber? Probably not. So I'm here for life. You've got me. It's terminal.
Cool, right? So that's Open Frameworks. So let me just talk about, in the time that I have remaining, I want to talk about some issues, or some interesting things about this that might tie it back to things that are interesting here. A lot of the problems are very similar to what people in the open source software of any kind encounter. For example, how do you make it economical? How do you, what do you do? How do you license it? So processing is GPL, and Open Frameworks is MIT. So both are very permissive, and people can use it in commercial projects. They can use it in closed source. Actually, one of you guys might be better at this. I'm not an expert. Can't use it in closed source projects. I don't know. We'll have to look that up. But they're very permissive Creative Commons licenses. And this is nothing new. There are people that work on Linux and OpenGL and VLC and Audacity and all these WordPress. These are all open source software stacks that have to deal with the same sort of issues. But for art, it's slightly differently because artists have to make a living also somehow. And digital art is definitely not in the mainstream art world by any stretch of the imagination. So really, the reproducibility of digital art makes it very hard to commoditize. We think of artists as being your Rothkos and your Van Goghs and people who have been locked away in a cabin with some secret technique. And open source software has really completely changed the dynamic of how art is created. It's become very collaborative, And sometimes in a lot of these projects, it's hard to tell who contributed what. So issues of authorship become very much dynamic and a lot more fluid than they otherwise would be. And so it becomes, this becomes an issue. I mean, who do you give credit to, or how can people commoditize it? How can people make a living? The nice thing about programming art is that programming is a nice skill to have in other contexts as well. So oftentimes digital artists can make a living doing things besides for their art, using the same skills that they know. A very common thing for people to do is to work on commercial projects on the side, or maybe as a living for clients. So for example, there's lots of these really nice, well-known artists. Yes, something I wanted to show when I thought I had a little bit more time for artists not making money. But companies like Fathom, for example, do these cool infographics for and help companies understand their own their own data, right? So big data is sort of this big buzzword. And a lot of artists can use the same computational skills for making these sorts of programs. I guess I have, what, like 1 minute? All right, so I should wrap up, yeah? Okay, okay, great. In that case, I'm going to wrap up, and there's a lot more, so please, come talk to me. I have so much more to share. I'm halfway through the talk, so. But are there any questions? Anything cool? I really covered all the bases. Yeah. Oh, yeah?
So I was wondering, actually, you hello? Hello? Okay. So I was wondering, you had mentioned that you do a lot of collaboration with other artists. So do you guys collaborate on GitHub? Do you share your code, or do you have other ways of collaborating? How do you? I'd be curious about that particular process for artists.
Well, anything that can be shared online, like the code, anything that can be put on GitHub. Sorry. Oh, sorry. If anything that can be put online, any code that can be put online, that's often really the best way to share code. So we can kind of keep track of each other. If there are multiple people on one project, it's really useful. Obviously, one of the programs that I showed you was the seashell fabrication one. And there are aspects of that which aren't code at all. So that obviously doesn't get put on GitHub except to maybe some documentation that goes on GitHub about that procedure. It's a whole other talk is about how open source is entering the physical domain.
Yes, actually, I was wondering, because we have things like people like authors who are collaborating on open source books on GitHub, and I've also seen when they do it, graphic artists they try to collaborate on images and things. So I was actually just curious whether you were exploring that space.
Yeah. Well, yeah, definitely. I think that's the best way to collaborate online. And any code, I think GitHub is such a great forum for it. One more big smile. This one's for my mom.